The impact of the generation of waste acids may largely be mitigated by implementing an effective regeneration process. In most cases, with most types of acids, a distillation process may be used to regenerate the spent acids into a reusable quality product. In an effort to understand some of the key fundamentals that drive the waste and recycling industry, we have developed a website, waste.net, to act as a tool to assist in grasping the 4R strategy of reduce, reuse, recycle, and recover. Within the 4R's recycling sector, chemicals such as spent acids may be conserved and may be converted into valued regenerated resources. If you wish to find a market to reclaim surplus or spent acid, you may add an inquiry to the Acid Recovery Exchange. The exchange service is a neutral platform that allows generators of acid waste to connect directly with users that can reuse or regenerate these materials. A link to add a listing has been provided in the comments. Any number of types of acids may be dealt with, but from our industrial suppliers, we most commonly encounter sulfuric acid, nitric acid, hydrochloric acid, and spent aqua regia. Sulfuric acid is known under the chemical symbol of H2SO4. Waste sulfuric acid is generated as a common industrial byproduct from many processes. Spent sulfuric acid currently may be being treated by neutralization or regeneration. Spent acid may be reconstituted by removal of contamination, concentrating and re-refining for use again. One common source of waste sulfuric acid is from the scrap lead-acid batteries used in cars and trucks. The boiling point of pure sulfuric acid is around 337 degrees Celsius or 639 degrees Fahrenheit, but it actually begins to decompose into sulfur trioxide, SO3, and water, H2O, when heated above approximately 300 degrees Celsius or 572 degrees Fahrenheit. HNO3 is the chemical formula for nitric acid. While nitrogen is an essential and safe inert gas that makes up over 78% of Earth's ambient air, nitrogen dioxide, NO2, is a highly corrosive oxidant and is considered to be a toxic gas. Nitric acid may be formed when nitrogen dioxide is dissolved in water. A market exists to trade in surplus nitric acid, and there are outlets for the safe treatment and handling of spent nitric acid wastes. Nitric acid is useful in the separation and the refining process of metals. Dissolving specific metals in nitric acid to form metal nitrates that may be further converted into pure metal is one refining and recovery approach. Closed nitrogen exhaust loops allow for the capture of nitrogen dioxide that may be sparged into a water column for regeneration as fresh nitric acid. The boiling point of concentrated anhydrous nitric acid is approximately 83 degrees Celsius or 181 degrees Fahrenheit, though it can vary slightly between 82.6 degrees Celsius and 87 degrees Celsius depending on the source and concentration. Since nitric acid boils at a lower point than water, operating a fine-tuned distillation column may separate and regenerate a concentrated nitric acid. Hydrochloric acid, known under the chemical symbol of HCl, typically refers to either surplus or spent hydrochloric acid. The boiling point of hydrogen chloride gas, HCl, is minus 85.05 degrees Celsius or an equivalent of minus 121.09 degrees Fahrenheit at standard pressure. This is significantly different from the boiling point of an aqueous hydrochloric acid solution, of which the boiling point is much higher and depends on the concentration of HCl in the water. Spent aqua regia is a mixture of concentrated nitric and hydrochloric acids. This is a combination of HNO plus 3HCl. It is a highly corrosive liquid that will dissolve gold and other resistant substances. This acid may not be regenerated directly to recover an aqua regia acid solution. The recovery process requires the decomposition of its reactive components in separate stages. It is common practice to neutralize metals containing acids such as spent pickling liquors and plating baths, with the use of caustic-based materials like lime. The neutralizing slurry is typically separated into a neutral dischargeable liquid fraction, and a wet solid fraction in a vacuum filter press. The wet solids are referred to as a filter cake and typically contain the metal residues. Acid neutralization filter cakes typically retain a high moisture content, with the bulk of the solids consisting of the mineral base materials such as calcium or lime along with all the residual metals. Further treatment of the filter cakes for the recovery of strategic metal values and trace heavy metals may be performed. This recovery treatment may provide the opportunity to conserve the water content and regenerate the minerals as the concentration and selective extraction of the metal residues takes place. The treatment and processing of acid wastes or materials generated from acid leaching operations are contained in a closed-loop system to ensure the regeneration on a mass balance equilibrium basis. A common example of closed-loop acid recycling is by capturing the fumes generated by nitric acid leaching and sparging them through a water column, creating a dilute nitric acid. This regenerated acid may be stored and cycled back into the leaching reactor as required, conserving the need for a fresh supply of acid and water. If a more concentrated acid is required, the distillation of nitric acid, with a boiling point of 83 degrees Celsius, may effectively separate the acid from the water. The leaching process generates voluminous amounts of rinse water or wash water into a wastewater cycle. Wastewater management is an integral part of a regenerative hydrometallurgy process. The conservation and regeneration of clean water is an essential function in the ubiquitous flow of H2O. We hope to discuss in further detail other specific aspects of acid regeneration along with the recovery of other chemicals at some point in the future. Until then, please feel free to contact us at your convenience. Waste.net provides a neutral platform to assist in finding a market for scrap, waste and byproducts, with the goal of matching waste material generators directly with beneficial users of those materials. By connecting market participants, we foster collaboration and promote environmental sustainability. Please feel free to visit us today at www.waste.net.